Betelgeuse or Betelgeuse is a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. Enormous, very unstable, and about to explode, they are among the biggest explosions of radio energy in the entire universe, generating more energy than a billion suns. Betelgeuse or Betelgeuse is a red giant star. If you put it where the Sun is, it would extend out to the orbit of Jupiter. Enormous, very unstable, and about to explode. When we think of stars, we probably imagine tiny, shiny items in the night sky. At least, this is how we see them from down here on the planet. But stars are something else entirely. In fact, one of the biggest stars, Betelgeuse, happens to be much larger than our Sun. For years, this star has baffled scientists, but recently something more unsettling has been happening with Betelgeuse, making scientists and other well-informed folks very, very concerned. Join us in this video as we explore the terrific news about Betelgeuse, its impending destruction as expected by the James Webb Space Telescope, and how this new development will affect our galaxy and our lives right here on the planet, as explained by physicist Michio Kaku. Betelgeuse is a cosmic wonder, a large star that has intrigued cosmologists for so long. A Greek astronomer named Tony was the first to discover it. This star is so huge that it can be seen in the night sky from Earth, particularly during winter. If you're into constellations, you've probably seen or heard of this star. It is the reddish-orange star that marks the upper left shoulder of the Orion constellation. So, you see, this star is ancient and, so far, one of the brightest stars in the night sky. But one thing about Betelgeuse's brightness is that it doesn't stay constant. Instead, it fluctuates. This fluctuation is one of the unique properties of the star, but it isn't the only one. Let's look at some of Betelgeuse's specific properties. Most of the stars you see in the night sky are actually far from Earth. The nearest star is 4.2 light-years away from Earth. If you don't understand how the term light-years explains distance, picture it this way. Consider moving at the speed of light for a whole year. It's been proven that light can cover a distance of 186,000 miles per second. Therefore, the distance light can cover in a year is equal to 1 light-year. If you do the math, you'll have billions of miles. So, when we say the closest star is 4.2 light-years away, it means it is billions of miles away from Earth. But guess what? Some stars are even farther, and Betelgeuse is one of them. Betelgeuse is located approximately 600 light-years away from Earth. So, if you were to travel to it at the speed of light, it would still take 600 years. We can't move that fast. Not even our fastest spacecraft can. But this star can still shine so brightly in our sky. If you're wondering how Betelgeuse can be so bright despite its distance, that's because of its other qualities like size and brightness. Betelgeuse is about 500 times larger than our Sun. Its radius is believed to be about 1,000 times that of the Sun. It's so big that it appears as a disk in space when using sophisticated telescopes, while other stars appear as little points of light. This appearance is suspected to be an effect of the reactions at the outer layers of its atmosphere. In terms of mass, Betelgeuse measures about 12 to 19 solar masses. A solar mass is the standard unit of mass used by astronomers. One solar mass is equal to 2 times 10 to the power of 30 kg. Scientists cannot determine the exact mass of Betelgeuse because there are no other planetary bodies orbiting around it to compare with, and of course we can't measure it directly from here on the planet. But it's proven that this star is at least 12 times heavier than our Sun. The brightness of Betelgeuse ranges from magnitude +0 to +1.6. In more familiar terms, Betelgeuse is 16,000 times brighter than our Sun. No wonder it was nicknamed a red giant. However, the brightness of Betelgeuse doesn't stay constant. It fluctuates. This fluctuation is due to its pulsations. In other words, Betelgeuse expands and contracts. When it expands, it gets brighter, but when it contracts, it dims. This process can last for 10 to 100 days or even more. One unique property of Betelgeuse is that its surface is covered in dark magnetic spots. The magnetic field in these regions is far stronger than at the normal surface, but the downside is that these strong magnetic spots inhibit the flow of hot gas to the star's outer surface, making the star cooler in these regions. The fact that Betelgeuse has lots of these spots compared to our Sun explains why it is cooler than our Sun, despite its size and brightness. The Sun also has its own dark magnetic spots, but those on Betelgeuse are much larger and very numerous. To give you an idea, the spots on Betelgeuse can be twice as large as Earth. Betelgeuse also boasts a magnetic field that is 1,000 times stronger than that of the Sun. This field is why, when viewed through a telescope, the gases on the surface of Betelgeuse appear to be in loops or arcs. Betelgeuse has a surface temperature of about 3,500 Kelvin. This low temperature contributes to the low energy emitted by the star and its dim red color. Betelgeuse is a red star, but it wasn't always red. It was yellowish about 2 million years ago, just like our Sun. Over the years, the color started changing to orange, red, and then, about 2,000 years ago, it slowly started becoming the red star we know today. This fact has made scientists believe that the star is aging. Betelgeuse emits as much as 7,500 times more energy than the Sun. It would have been a fierce rival to Earth's Sun if it weren't so far, far away. In its prime, the fact that Betelgeuse, which is 600 light-years away, can still be seen and identified with the naked eye at night is quite remarkable. Our Sun is only 8.3 light-minutes away from Earth. That's why it's so powerful. If Betelgeuse were just slightly closer, we would also be able to see it during the daytime. But if it were to replace the Sun, it would swallow up or displace the Earth and the other 4 planets near it because of its enormous size. Furthermore, even if it could match it, it emits more radiation than our Sun. Betelgeuse, also known as Betelgeuse, is a supergiant star located in the constellation Orion, approximately 600 light-years away from Earth. Its immense size is one of its most striking features. It is about 500 times larger than our Sun in terms of radius and could easily encompass the orbit of Jupiter if placed at the center of our solar system. This colossal size allows Betelgeuse to appear as a distinct disk rather than a point of light when observed through powerful telescopes. Unlike most other stars, despite its enormous size, Betelgeuse is not the most massive star. It ranges in mass from about 12 to 19 times that of the Sun. This variability in mass estimation is due to the challenges in accurately measuring the mass of stars that lack a companion star or other objects to provide gravitational reference points. Nevertheless, even at its lower estimated mass, Betelgeuse remains a significant stellar object. The brightness of Betelgeuse is another noteworthy characteristic. It varies regularly over time, with its brightness ranging from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be 16,000 times brighter than our Sun. This variability is attributed to its pulsations, periodic expansions and contractions caused by internal processes within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it dims. These pulsations can last for days to months, contributing to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a large star, measuring around 3,500 Kelvin. This gives it a distinct reddish-orange hue, characteristic of red giant stars nearing the end of their life cycle. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has exhausted the hydrogen fuel in its core and begun fusing heavier elements. This fusion process generates energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena. It exhibits dark magnetic spots on its surface, which are significantly larger and more numerous than those found on our Sun. These spots are regions of intense magnetic activity that inhibit the flow of hot gases from deeper within the star to its surface, contributing to cooler spots on the star's surface. Betelgeuse's history and cultural significance also make it a prominent celestial object. Known since ancient times, Betelgeuse has been observed and documented by various civilizations throughout history. Its visibility in the night sky, particularly during winter in the northern hemisphere, has made it a prominent feature in constellations and mythology. In recent years, Betelgeuse has garnered increased scientific attention due to its dimming episodes, which began around late 2019 and continued into early 2021. During these periods, the star's brightness dropped to unprecedented levels, sparking speculation among astronomers about its imminent fate. Betelgeuse, also known by its astronomical designation Alpha Orionis, is a fascinating subject of study in the field of stellar astrophysics. As a red supergiant, Its enormous size, variable brightness, and complex magnetic activity make it a valuable object of research for understanding the life cycles of massive stars and the physical processes governing their behavior. The most concerning news about Betelgeuse is that it's nearing the end of its life. Scientists believe it will soon undergo a supernova explosion, a cosmic event of immense magnitude. This event occurs when a massive star exhausts its nuclear fuel and collapses under its gravity, leading to a catastrophic explosion that releases an enormous amount of energy and matter into space. Although Betelgeuse is approximately 600 light-years away from Earth, such an explosion could have significant consequences for our galaxy and potentially impact our solar system. Fortunately, the distance provides a safety buffer, and any effects on Earth would likely be minimal. However, the explosion could contribute to the formation of new stars and potentially influence the dynamics of the interstellar medium in our galaxy. The James Webb Space Telescope, JWST, has been monitoring Betelgeuse and has observed recent changes in its behavior, contributing to the growing concern about its imminent supernova event. The telescope's advanced imaging and spectroscopic capabilities provide valuable insights into the star's properties and its evolving state. Michio Kaku, a renowned physicist, has offered explanations about the potential effects of Betelgeuse's explosion on our galaxy and our planet. He has emphasized that while the event is significant, the distance of 600 light-years provides a considerable buffer, and the primary impact would be on the stellar environment rather than on Earth itself. In conclusion, Betelgeuse is a remarkable red supergiant star with extraordinary size, brightness, and variability. Its impending supernova event, monitored by advanced telescopes like the James Webb Space Telescope, presents an exciting area of research in astrophysics. While the explosion may have minimal direct impact on Earth due to the vast distance, it remains a profound and fascinating cosmic phenomenon that continues to captivate scientists and the public alike.